Welcome to another practical physics walkthrough. The aim of this is just to give you a little look at the equipment and have a rough idea about how to use it before you come into your lab. And today we're going to be looking at the magnetic flux linkage experiment. So we're going to be using some Helmholtz coils and a search coil and a cathode ray oscilloscope just to investigate how the effective angle on induced EMF. So let's have a little look at the equipment. So let's get rid of me so you can see what's going on. So there's a couple of different types of Helmholtz coil. This is one setup, so you can see it's a little bit smaller. And over here we've got a bigger setup. It's exactly the same system, but just with a bigger set of coils. Just for ease, I'm going to use the little one today. You'll notice that there's some wires pre-plugged in, so you need to make sure that you leave those untouched. Does it really matter what power supply you use? Not particularly, but I suggest using a continuously variable smooth one because that'll be easiest for you. And we've got a cathode ray oscilloscope which we're going to be using. So we need to be able to connect that up. You can use normal cables for this, but the cathode ray oscilloscope has got a special, we call a BNC cable, and I'll show you that in a second. So this is a BNC connector, and you can see that it's got, I'm struggling to focus, but you can see that it's a little twizzly thing, and it connects to the bayonets on the cathode ray oscilloscope like that. These connect to the search coil, and need to be a little bit careful with this, because although we've tried to make it as strong as we can, it is not perfect. So the CRO gets connected to this thing, which is the search coil. I'm going to take it off now very, very carefully. I do not want you to take it off. Okay? So we've put this kit all together so you don't have to search for the search coil and all the other bits of kit. As I say, I do not want you to take this off. But you can see it's literally just a coil of wire and a little core in the centre, and it's just on a stick. And the basic gist is, when an alternating magnetic field, or when a changing magnetic field gets passed through that coil, it will induce an EMF. Right, let's connect these up. So, two completely separate circuits. The power supply chucked in an ammeter just to be sure what we're doing, and we've got the Helmholtz coils there. We'll just put it into, doesn't matter which end you plug them into, it's an alternating current. So let's turn all this on. Always start off with this at 0, make sure it's on AC, make sure this is on alternating current. I'm going to put it on the 10 amp scale. I'm pretty sure for this you're not going to be able to get it above a couple of amps anyway. And we've now set this up identical to this diagram. We want to set it to 1 amp, so actually I will put it on the 1 amp scale, on the 2 amp scale. So 2 amp alternating scale on here, connected here, hopefully the fuse isn't blown. As I crank up the voltage, I do not care what the voltage is, I'm just after the current. So I'm just going to wang this up, 0.6, 0.7, 0.8, and I'm going to try and get as close to 1 amp as I can. Just drifting a little bit. That will do. Okay. Sometimes when you first use a cathode ray oscilloscope it can be a little bit daunting, but as long as this is all these are nice on the top. We're looking at channel 1. This will change how many volts per div are seen here. So we've now just got noise. Actually, I'll just turn this around so we're actually seeing it. And oh, okay. If you've got it so that when you move the wire, you're losing the signal, it means one of the wires is broken here. Let's get another wire. Okay, this looks a bit weird probably on the video because this is flickering and obviously there's a flickering on the recording as well. But there's not a lot I can do about that, so this is just going to look a bit weird. I will try and change the time base so that it's not going to look good, but it's not flickering too badly for me. As it happens, we're not going to use this anyway, because what we're going to do is we're going to turn off the time base so we just get a vertical line, and the size of this vertical line is the peak to peak voltage. Now what we have to do is, I'm just going to zoom in a little bit. The experiment, you effectively just twizzle this dial and read off the angle that this search coil is at in relation to the Helmholtz coils. So at the moment there's an alternating current going through these coils which creates an alternating magnetic field, and that's pretty uniform actually. And this alternating uniform field, if there is such a thing, is creating an induced alternating EMF in the search coil, which is being picked up here. So as I twizzle this from flat on to the coils or to the field through to 90 degrees to it, we see that, and this is 90 degrees to it, and as I slowly bring it round so the face of the coil is parallel to it, so the full face of the coil is being seen by the field, you can see I've got a larger EMF. The experiment is measure the EMF, compare it to the angle, and you'll get a lovely graph if you look at cos of the angle versus the EMF. And from that you should be able to find the flux linkage, which on the sheet is VAN, and that is the crux of the experiment. There's all the information you need in the worksheet, and hopefully now that you've seen this setup you'll have no problems finding the equipment and setting it up.